It's just you today. That's exciting, isn't it? I should just give like a pop quiz and you get a 100 because you're here. Everyone else gets a 0. Hopefully they show up. You look at probability, so we're starting probability today. That's kind of really, I don't want to say it's all we do for the rest of the semester, but probability plays a big part in what we do for the rest of the semester. Okay? So we start with just some basic introduction to probability theory. Oh, there's everyone.
I just looked at the time and I was like, it's already 12.
So let's do a basic introduction to probability theory. So just look at the basics of probability. Then we'll be looking at random variables after this, which is still a part of probability theory. Theoretical probability is the obviously the theory behind probability. So doing an experiment is not actually necessary to calculate a theoretical probability. So what we do is we just use either general knowledge of the situation or previous knowledge from experiments done before or known formulas. There are 3 ways of writing probability: as a ratio, as a decimal, or as a percent. The law of large numbers says that as a probability experiment is repeated over and over and over, the proportion of times that a given event occurs will approach its probability. Right? So, as an example, consider a fair coin. How many outcomes do you have when you flip the coin? That's a probability. How many outcomes do you have? 2 of them, right? Heads or tails. For a fair coin, what's the probability of getting a head on a single flip? 50%, right? So if you flip the coin 100 times, will you get exactly 50 heads? You may. You may not. You may get maybe 52 heads. Maybe you'll get 47, 46 heads. If you get 95 heads, you're going to think something's off. Right? Now, that is possible to get, but it's kind of odd, right? What the law of large numbers says is if you repeat that experiment over and over and over and over again, you'll see that it's going to, what we call, converge to 50. To 50 heads. That's what the law of large numbers is saying. Sample space is just all the possible outcomes of a probability experiment, right? So again, the flipping of the coin, your sample space will be heads or tails. Right? Heads, tails, it's a set. An event is the occurrence. You flip a coin. How it lands is the event. A probability model consists of your sample space along with the probability for each event. And probability is typically denoted as a capital P. Right? So if the event is labeled as A, then P of A is the probability that event A occurs. When you have equally likely outcomes, so all of the outcomes in your sample space are equally likely to occur as the other, fair coin being flipped, a fair six-sided die being rolled, they all have equally likely outcomes, then the probability of event A occurring is the number of outcomes in A divided by the total number of outcomes. Probability is always between 0 and 1. Wait, I even made it bigger and it's still not working. This is if the probability is written as either a fraction or a decimal. It's going to be between 0 and 1, which is the same as 0% to 100%. Listed on here. And so characteristics, already mentioned that one. Probability is always between 0 and 1, inclusive. Okay, yeah, so they are on. If event A is impossible, its probability is 0. And so probability of 0 means the event cannot happen. Probability of 1 means that the event is guaranteed to happen. Unusual event is just an event that has a very low probability of occurring. There are several different probabilities that are used. The most common one is 5%. So if an event has a probability less than 5%, we say it's unusual. Sampling an individual from a population is an experiment. The population would be your sample space. The members of the population are equally likely outcomes. And then the empirical probability or the experimental probability of an event occurring. We calculate this by just repeating an actual experiment a very large number of times and finding the ratio of the number of outcomes in which the event occurred over the number of trials. So first, this is a bit of trivia for you. I'm not really going to need to know it. but we said that a probability of 0 means it's impossible for an event to occur. Realistically speaking, there's no such thing as an impossible event. So you give me any event, there is actually a probability of it occurring. It just, how low is it? Second, and this is a misconception. Let's say you're taking the SATs. You come across a question, you have absolutely no idea. SATs are what, 5 choices? I think it's 5. I think it's A, B, C, D, E, usually. We'll go 5. You put down B. What is the probability that you're right? So you say 20%. So anyone who disagrees with that? It's not 20%. You chose B, right? Has a fixed answer, doesn't it? The answer is A, you have a 0% chance of being right. The answer is B, you have a 100% chance of being right. The 1 in 5 is what is the probability of randomly guessing the right answer? Not once you have the answer, what's the probability of being correct? That's an important distinction in probabilities. It has to be random selection. What we want to do first, we're going to be given an experiment and we want to give the sample space. And so remember what the sample space is. It's the collection of outcomes. You roll a 6-sided die. Sample space typically represented with a capital S. What are your outcomes? 1 through 6, right? That'd be a sample space. You flip a fair coin twice. Could get 2 heads, right? You could get a heads and a tails, but there's 2 ways for that to occur. we could get 2 tails. That is our sample space. Roll a fair 6-sided die and flip a fair coin. The flipping of the coin has 2 outcomes, right? Heads or tails. The rolling of a 6-sided die has 6. There's a total of 12 outcomes then. That'll be the sample space. So consider the experiment rolling a fair 6-sided die. And again, it's important that it's fair, because that means all outcomes are equally likely. We want to calculate 4 probabilities. While I will generally not list out the sample space each and every time, for getting started, we will. One at a time. Start with the probability of rolling an odd. Probability would be the number of odds divided by the number of outcomes. Right, so it's the number of outcomes in your event divided by the number of outcomes in your sample space. How many odds are there? What are they? Right, so the event odd is 135. How many total outcomes were there? Probability is 3 out of 6. Which is exactly 1/2. What is that trying to find? So what are we looking for here? What is it? The probability of being less than or equal to 4. So how many outcomes are less than or equal to 4? Four of them, right? Four out of 6, which is 2/3. 0.667. Actually prefer 4 decimal place line. There we go. So I'm going to add 1 to that as well. So probability that it's prime. Who remembers what a prime number is? Oh, that does just make me very, very sad. What is a prime? What does it mean?
It's when a number is only divisible by 1 itself.
When it only has 2 factors, one in itself. There is actually a second stipulation in the definition. Technically 2, but they combined into 1. Has to be greater than 1. Negative numbers aren't prime, unless I'm misremembering my number theory course, and 1 itself is not prime. So you're right, there are 3 primes in there. What are they? 2, 3, 5. Two is the only even prime number. That notation shorthand for not. That means we're looking for the probability that we do not roll a 6. Number of values that are not equal to 6 over the total number of values. How many values are not 6? This is fairly easy. 5 out of 6. Which is 0.8333. Fair 6-sided die is rolled once. Calculate the following. That means or. I'm not sure if it's in this example set. It doesn't look like it is. But that would be shorthand for and. How many ways can you roll a 3 or a 4? It's not a trick question, it's really straightforward. There's 2, right? Out of how many outcomes are there when you roll a 6-sided die? So this probability is 2/6. And the probability of rolling a 1 or 2 or 6. would be 3 out of 6, right? Let B represent a boy, let G represent a girl. Assume each birth is equally likely and independent. Single family with 3 children. Oh dear. So I'm not an English major. Is randomly selected. English is very hard. So I like math better. It's easy compared to English. Want to list the sample space first. But when trying to determine a sample space, sometimes it's nice to create a tree diagram. 2 ways you can draw a tree diagram. You can either draw it vertically or horizontally. Then you want to draw it vertically. Horizontally. So we know that the family we're choosing has 3 children. For the first child, what are the outcomes? Or, right? You have 2 outcomes, boy or girl. For the second child, what are the outcomes? Is that going to depend on what the first child was? What are the possibilities for the third child? This is our tree diagram. Here you can easily see the sample space. And just follow the branches. That takes care of the first child was a boy. And if the first child was a girl. There's your sample space. So this is just a, actually, it's not really tricky, this is actually quite useful. If it's just one child, how many outcomes were there? If it was two children, how many outcomes are there? 3.
Oh, wait,
Yeah, if there's 3 children, how many outcomes?
8.
So how many outcomes do you think they're going to be if there's 4?
12. 16.
16. Use that pattern. 10 children, how many outcomes are there? What is it? $1,024. It's 2 to the 10th power. 20 children, there'd be 2 to the 20th outcomes, which is 1024 squared, which is over 1 million. Yeah, probability also requires you to know how to count. And counting is actually hard. You think it's easy, it's actually hard. There is a branch of mathematics called counting theory. I'm not done yet. So that was just A. Now, what is the probability the family will have exactly 2 girls? Well, it's going to be over 8, right? Because there's 8 total outcomes. Look in your sample space. How many of them have exactly 2 girls? How many? There's 3 of them. The probability is 3/8. Which is exactly 0.375. Or 37.5%. Probability of at least one boy. What is it? There's 7 outcomes. In fact, the only one that doesn't have at least one boy is the outcome of only girls. That's 0.875. Fair six-sided die is rolled once, and a fair coin is flipped once. Calculate the following. Oh, there is and there. Okay. Just for reference, that's the sample space from the first question. And I think I'll split this into different slides. What is the probability of rolling ahead flipping ahead or rolling greater than or equal to 5? Let's just look at the outcomes where there's a head. Right, so that would be if it's a head. Or greater than or equal to 5. So now look at all the cases where there's greater than or equal to 5. How many is that? You don't count it. You don't count the same outcome twice. Eight out of 12. Which is 2/3. Probability of it being heads and rolling an odd. Those are all the heads, right? Odds. This one is and. So how many are there? What is it? Those 3. Because it's and. You want a heads and an odd. So both have to occur. Last one was or. Only one of them had to occur. Three out of 12, which is 1/4. Let's see if you can do this one without me underlining it. How many outcomes are tails and 6? Just one of them. 112. Point 0833. Survey of 4,000 students records out-of-pocket annual costs. Results are in the table. A single student is selected at random. What is the probability that that single student's out-of-pocket annual cost is $55,000 to $64,999? Now this is even easier because they gave us a table that counts. There's 580 of them out of how many? Out of 4,000. That's your probability. Point 145. Probability of the annual out-of-pocket cost is greater than or equal to $65,000. Bless you. 280 out of 4,000, right? .07. 4 decimals. Probability of the annual out-of-pocket cost is less than $25,000. So how many students had an annual out-of-pocket cost of less than $25,000? How many? So the 1,300 is for $25,000 to $44,999. Just the 650? Because I agree that would definitely be less than, that category is less than 25,000. Is that the only category less than 25,000? Also the 240. How many total? 890. 0.2225. And what is the probability greater than or equal to 5? So greater than or equal to $5,000. Every single one of them?
No, like, starting at 650.
There's an easier way of doing that. Because you just said it's everything except for that 240, right? Just take 4,000 minus 240. What's 4,000 minus 240? Make it easier. It's 4,000 minus 200.
3,800.
Subtract 40 from that.
3,760.
There you go. 3760. .94. This one's fine. Look at this, number 9. That's what I'll find. 6-sided die is rolled 800 times. Three occurs 140 of those times, a 4 occurs 128 of those times, and a 1 occurs 135 of those times. The same die is then rolled again. What is the expected probability of rolling a 3? Well, how many times in this experiment did a 3 come up? And how many times was the experiment repeated?
800.
That would be the probability. .175. And probability of a 4? That is 0.160. Let me just double check that. Yeah. 1600. The probability of rolling a 1 and probability of rolling. Something about that. My hand was not in the right spot. Expect the probability of rolling something other than a 1. What is it? So how many outcomes would it be? I said that wrong. Wouldn't be a 1. How'd you get 268? What about 5? Isn't that something other than 1? What about 6? What about 2? So if 1 rolled 135 times, how many times did a 1 not roll? The every other time, right? Which is 665. How'd you get it? 800 minus the 135. And that is, let me just double check. 831, oh, here's 125. 8313. You roll 2 fair 6-sided die. What is the probability of getting a 7? The first thing you have to determine is how many possibilities are there? It's just counting, right? Here's the easiest way to look at it. You're rolling 2 die, right? How many outcomes are there from the first die? How many outcomes are there from the second die? What's their product? There's 36 outcomes. Of those 36 outcomes, how many of them are a 7? You can get 1 and 6, which is also 6 and 1, right? So that's 2. 2 and 5. There's 4. 3 and 4. 6. I'm double counting each one because rolling in reverse gives you also that. 6 of the 36. That would be a probability. That's 1/6. What's the probability that the sum is 6? So how many of the 36 outcome is 6? Yeah, you can do 1/5 or 5/1, so that's 2. 2/4 or 4/2, that's 4. 3/3 or 3/3. They're saying 5 and not 6. Should be 6 out of 36 as well. And we'll double check that. They have 5 out of 36, and I don't think that's correct. I know why they have it. They're saying that rolling a 3 and then a 3 is one event, not two. It should be 2. Is it? No, it is. No, it is 1. Rolling a 3 and a 3 means you rolled a 3 on the first die and a 3 on the second die. There's only one way to do that. And that's both 3. Yeah, okay, I'm back. It is 5 out of 36. Whereas if you roll a 2 and a 4, there's 2 ways to do that. 2 on the first, 4 on the second, or 4 on the first, 2 on the second. So that is 5 out of 36, which is 1389. Probability of a 12. There's only one way to do it. You have to roll 6 on both. That's 1 out of 36. Oh, 2. Okay, good. What's 17? 0278. And what's the probability at least 1? Shows a 6. Well, if you roll a 6 on the first die, how many outcomes can you have after that? 6 of them, right? Second die rolls of 1, 2, 3, 4, 5, 6, and that's at least 1 6. The second die was a 6. How many outcomes on the first? 6 as well. That's 12. Oh, but wait, you double counted. They're both 6. So it'd be 11 out of 36. .3056. stop anyway, but that one I can't do yet. I'm gonna need to do conditional, not conditional, sorry, the additive rule for that, which is not next week, the week after. So I'll come back to this one if I remember. It's 2 weeks away. And I'll let you look at that one. Questions from today? Hardest part of probability is counting the number of outcomes. As a reminder, next week, we're actually not doing anything new. I booked Tuesday to just do review problems, and then Thursday will be the midterm. Don't forget, your first group assignment is due next week, next Tuesday. It is English class. So for the last 8 minutes or so, I'm going to hand out the worksheet. If you want to work on it, be my guest.